Hey, everybody. Okay, it's right at 4 o'clock. I just posted an announcement about the final exam, posted it in Ivy Learn. There's going to be 40 questions on it. I'll give you 4 hours to take it. It'll open right at 4 o'clock on Wednesday, so there'll be no Zoom meeting on Wednesday. So this is our last meeting. Oh! Anyway, I said to take pictures of your paperwork. You can use your calculator. You can use any notes you have. But like I said, it's a 4-hour window this time. So you should have plenty of time to take it. And when you're done, take pictures of your paperwork and send them to me through messages in Ivy Learn. Don't email it to me. That way it's all within the class and I can keep them all in one spot. Because email, I get so many ridiculous emails and they all get spread out and it's hard to keep up with an email. So I'm gonna stop using email. And then,
Hey, April,
yes.
my phone's been acting funny. I'll try, but what if it doesn't get through?
What do you mean?
I can take pictures sometimes and send it, and it's like I don't know if it's data or what, but it's like it will show up and it's just nothing there.
On your phone?
Yeah.
What kind of phone do you have?
An older one, but it works most of the time.
Well, if you can't get it through Ivy Learn, then send me a message in Ivy Learn saying that you sent it via email. If that's the only way you can get it.
I'm just kind of, I'm a little bit, yeah, I know. To send it through Ivy Learn, how we would, I guess you send it to yourself first and then.
Yeah.
And then you would send the email to you then, right? Or not the email. I mean see, I'm just kind of confused on how to do that. I'm sorry.
On your computer?
Like on the paper, yeah. You would take a picture of your paper.
And then you could email it to yourself.
Email it to yourself.
And then open your email and save the pictures that you took to your computer.
Okay.
Yep.
Okay.
And then just upload them into Ivy Learn.
All right.
Does that make sense?
Yeah.
And then the other thing I just went in and did was I decided to drop your 3 lowest My Math Lab assignment grades. And that's already been taken care of, except the last 4 assignments, 6.5, 6.6, 6.7, and 6.8. I've given you until tomorrow night at 11:59 p.m. to finish that up. So if one of those is one of your 3 lowest grades, on Wednesday when it's all done and I update, whatever's your 3 lowest grades will be dropped. Right now it's already dropped whatever your current 3 lowest grades are. But if those last 4 sections, if 3 of those are your lowest grades, then it'll be adjusted after tomorrow night.
So theoretically, if we were to just do, because you know how 6.8, I think it is like only 5 or 6 questions. It's really short.
Mm-hmm.
So I'm not saying I'm going to, but could I just do that one and then if the other ones are just zeros, then they just don't exist?
Right. Yep.
Okay, I'm not going to do that, but okay.
Yeah, because those things might be on your final, so I wouldn't do that. Yeah. I wouldn't do that. But yeah, theoretically, yes. But I noticed when I was looking at grades, as soon as I did the dropping of 3 grades, everybody's grades came up. I mean, whoop, so if there were 3 zeros out there, some of you went from C's to B's and D's to C's, and they went up, so it helped. But your final is worth 35% of your grades, so keep that in mind. Okay, so I had uploaded the review, was it Saturday morning, and then I did the answer key. I wrote it all out by hand and finally got that done. And took pictures of it. I actually have an app on my phone called Adobe Scan, and I take pictures with the Adobe Scan app, and it converts my pictures into a PDF. So that's something, James, if you have a, well, you said it's an old phone, so I don't know if you get apps or not, but it's called Adobe.
I'm just nervous because I don't know if it's me or the stupid phone, but it acts funny sometimes. I'll do my best. I'll get something to you. I promise.
Okay.
I'll do it.
Okay. But anyway, so has anybody had a chance to look at that? Let's see. I'm going to pull it up right now.
The final, you mean? Yeah, I had a couple. The function. I disagree with a couple of your answers, and I'd like to go over them.
That, like I put at the top note, there's always a possibility that I made a mistake because I was multitasking and trying to get that done and other things done. And let's see, there's that. And I want to make this much bigger. Let me shrink our pictures. Okay, but I also want to do this. So let's see, give me a second here. There's that, and there's that. Okay, so I'm gonna try to use my whiteboard on this. So what was your question, James? Which one?
Just a second. Let me find it on my thing here. Hold on.
Okay.
The first one was number 8. I came up with 5 with 2 under the square root, x squared. I probably just didn't take it another step. And then I have x under the square root minus 8 with 2 under the square root, and then x square root of x plus 3 square root of 2 square root of x. I probably went off the line somewhere, but mine was different than yours, and I wanted to see if who's right and who's wrong.
Okay.
It's close, but there's little differences.
All right, so this is number 8. All right, what I did was I broke each one down separately and with the numbers and the letters separately. And when I started with the numbers, like the 50, I broke the 50 down to be the square root of 25 times the square root of 2. The square root of 25 is a 5, but I cannot take the square root of 2, so it stays under the radical. And then on the x to the 5th, I broke that down to be the square root of x to the 4th times the square root of x to the 1st, because the square root of x to the 4th is an x squared. I cannot take the square root of x to the 1st, so that just stays like that. But then this whole mess, I have to make it look more algebraically pleasing to the eye. So the 5 and the x squared, those actually came out from under the radical. So you would write that as 5x squared. And then the square root of 2 and the square root of x, which are both under the radical, they would stay under the radical, but I would just use one radical. So that's how I got 5x squared times the square root of 2x for that first one. And then on the next one, the 128, I broke that down to be the square root of 64 times the square root of 2. And the square root of 64 is 8. I cannot take the square root of 2, so the 2 stays under the radical. And then the x cubed, I broke that down to be the square root of x times the, the square root of x squared times the square root of x to the 1st, because 2 and 1 is 3. And the square root of x squared is x. But I can't take the square root of x to the first, so that's just square root of x. And then this is, technically these are all multiplied together, so I just make it a little prettier. And there was a subtraction sign up here, so that subtraction sign is still here. And the 8 and the x, I like to say that they were freed from radical land, and they come out front. Here's 8x. But the 2 and the other x are still under the radical, so that's the square root of 2x. And then the last one has an 18 and an x. The 18 I can break down to be the square root of 9 times the square root of 2. I'm looking for square rootable numbers, and 9, the square root of 9, that's 3. And this x is under the radical, and I can't break that down. That's just x to the first. You cannot take the square root of an x. So I still have the square root of a 2x next to that. So I would add to it plus 3 times the square root of 2x. And that's where I left it because technically they're not like terms. I've got 5 x squared square roots of 2x's. And then I have negative 8 x square roots of 2x's. And then I have plus 3 square roots of 2x's. If this had just been 5 square roots of 2x minus 8 square roots of 2x plus 3 square roots of 2x, 5 minus 8 is negative 3, and negative 3 plus 3 would be 0 square roots of 2x, which would be 0. But because I had this x squared and this x here, and then there's no x on that last one, they can't be combined. So I couldn't do this. You could factor out. I mean, I suppose it didn't say to leave my answer in factored form though. I mean, they all have that square root of 2x in common. So you could have factored it out and then put 5x squared minus 8x plus 3, I suppose, but the directions did not tell me to do that, did it? Wait a minute. Yes, it did. Shit, sorry. Leave your answer in factored form. Well, son of a bun. Yeah, it did say leave it in factored form. Okay. There you go. I forgot to factor out my 2x. Oh well, I would have taken it either way. Does that explain that, James?
Yes, ma'am.
All right, so that's 1. What's next?
On test 2, problem 9, I believe that, if I am not mistaken, is a function because every domain has one range, and it fits the line test. If you were to make math, biology, psychology, and English, like 1, 2, 3, 4, and range 101, 123, and 136, if you were to make those like 5, 6, and 7, and then you were to, plot that on a graph, if you do, the vertical line only goes through once. Maybe I'm wrong, but I think that
right. Nope,
is a function.
Right. You're right. I don't know what I was thinking. Number 9 is a function. You are correct. Every x has to go to at least just one y. Every input has to have one output, which it does. Math only has one output. Biology only has one output. Psychology, I don't know what I was thinking. Sorry, it is a function. Sorry. I heard that.
I'm sorry, I'm just joking.
That's okay. All right, what else?
If you had time, the only other one I had a little trouble with, I guess because it's been so long, is the number 20, the word problem, the mixture problem. If you could go over that, that's cool. But if you can't, I understand.
Nope, so that's what this time is for. Where is that one? Back at the beginning?
Yeah, it's problem test 2, or no, that's actually on test 1, the last problem.
Yep, okay, got it. All right, so let's see if I can get this in here. All right, so number 20, the manager of a coffee shop has 2 types of coffee. French almond coffee sells for $12 a pound, while salted caramel costs $6 a pound. The manager wishes to mix 50 pounds of the French almond with some salted caramel to get a mixture that sells for $10 per pound. How many pounds of the salted caramel coffee should be used? Okay, I am just going to use, let's see, the letter F for French almond. And French almond sells for $12 a pound, right? So it's $12 for every pound of French almond. And the salted caramel, I'll just use C for caramel. That one costs $6 a pound. And they're going to mix them together. So when they do the mix, the mixture will be $10 a pound, and that will be the 2 mixed together. So I'm just kind of jotting some stuff down here. The only other number they gave me was 50. He wishes to mix 50 pounds of the French almond. So I know how many pounds I have right here. I have 50. So he's going to take 50 pounds of French almond that will cost $12 per pound. He's going to add that to this caramel stuff, and that's what they want to know. How many pounds of salted caramel should he use? So that's my unknown. And when you're done, it's going to cost $10 per pound. And here's the tricky part. It's however many pounds of French almond. I know that that's 50. Added to how many pounds of the caramel stuff. I don't know that, so that's C. Oops, where's my $10? And the 10 goes right here. I don't know why I'm putting my dollar signs in here. I don't need them. That's the equation that I would solve for C.
The last part is where I messed up. Thank you.
Okay. So let's see, what's 12 times 50 is 600, I believe, plus 6C. Then I would distribute the 10 over here, and I'd get 500 plus 10C. And then I'm gonna subtract 6C on both sides. So I'll have 600 equals 500 plus 4C. And then I will subtract 500 on both sides, cancels that. And that gives me 100 equals 4C. And when you divide 100 by 4, you get 25. And this is 25 pounds. So 25 pounds of salted caramel. Does that answer my, yep, I got the answer right, woohoo. Any other specific questions on anything? Maybe if you haven't looked at it yet, maybe glance over it, and there's something you're like, oh gosh, I totally don't remember how to do that. Go over that, please, right now. Do you guys remember how to do number 8?
I think I could go over that one.
Okay. James, can I clear my screen?
Yes, thank you.
Okay. All right. Number 8 is simplifying an expression involving the imaginary number I. The basic rule, they want you to write the complex number in standard form. And standard form is a plus bi. This is 2 over an a plus bi. You cannot have an I in the denominator. So what you're going to do is what they call rationalize it. And you just multiply it by its conjugate. So 3 plus I, I'm going to multiply that by a 3 minus I. Because when you take a binomial times its conjugate and you FOIL it, outsides and insides always cancel out. And that gets rid of your i's. And then last times last, when you do an I squared, you have to remember that I squared always equals, it's the square, I is the square root of -1, and you're going to square that. And the square cancels out the square root, so I squared is just a -1. So over here, on the numerator, I'm going to distribute the 2. So that's going to give me 6 minus 2i. And then the denominator, I will FOIL first times first. 3 times 3, that is 9. When you do your outsides, you get minus 3i. And when you do your insides, you get a plus 3i. And those always cancel out. And then last times last, it's a positive times a negative, so it's a negative. And I times I is an I squared. But I squared is really a -1. So what I really have down here is this 9 minus -1, which is 9 plus a +1, which is a 10. So my denominator is a 10. And then I have to make it look pretty. It has to be in the a plus bi form. So you are literally going to split this up. You're going to give the 6 his own numerator space, and then you'll have the minus sign here and the 2i over there, and they each get their own denominator of a 10. And then you have to reduce it because 6/10 reduces, you can cut that in half to 3/5 minus the 2/10 becomes 1/5. And then the I technically should kind of be popped out over here on the side of the 1/5. And then that is my complex number in standard form. Good?
Good, thank you.
All right, anybody else out there looking at this and got something they definitely want me to go over?
How many questions are going to be on the test?
40.
And how much time will we have to complete the test?
I don't know if you came in late or not, but I posted an announcement about it. There's 40 questions and you'll have 4 hours. And then when you're done, take pictures of it and send them to me through the Ivy Learn messages, if you will. Not email, because my email box just is flooded with so many non-student emails that student emails seem to be getting lost. So I want to go back over some factoring stuff to make sure you guys remember that. Let's look at, yeah, number 3 is a good one. I'm going to go back to number 3 because that kind of covers all sorts of factoring in one problem. You've got says factor the following completely. And whenever they tell me to do that, I know I may have to factor and then factor again. So I always try greatest common factoring first. And so I look at the 12, the 52, and the 40, and I try to find the largest number that I can divide out of all three of those. Now they're all even, so I know they're all divisible by 2, but they're all also divisible by 4. So I know I can pull out a 4 on that. Then I go and I look at the variables. I've got an x cubed and an x squared and an x. And for those, the most I can pull out is a single x. You can get an x out of an x, and then you can get an x out of an x squared and an x out of an x cubed, but you can't get an x cubed out of an x. So x is the greatest common variable I can factor out. And then basically what you would do is you would like take each one of these and divide it by the 4x. And then whatever you get is going to go here and here and here. So 12x cubed divided by 4x would be a 3x squared. And then 52 divided by 4 is 13. X squared divided by x is x. Minus 40 divided by 4 is 10. And of course the x's cancel. So that's step 1. But now I've got this 3x squared minus 13x minus 10, and I got to try to factor that. And that is one of those trinomials that's the most difficult to factor because it has a coefficient on the x squared. If it was just an x squared, I'd just unfoil it, you know, x and x, but it's a 3x squared. So you can try to do it by trial and error if you want, but I like to use that thing called the AC method. I would take the 3, multiply it times the negative 10. 3 times negative 10 is negative 30. And then I would look at all of the factors of 30, which here they are. And I need the pair, and I'll keep in mind it's a negative 30. So one of these numbers has to be positive. The other has to be negative, and it has to add up to this negative 13. So that's going to be a positive 2 and a negative 15. I would use this pair. And you literally just rewrite this. You're still going to have your first term, which is 3x squared, and your last term, which is a minus 10. But you take the negative 13x out and you replace it with a plus 2x minus 15x. This trick just puts back outsides and insides, and then you just factor it by grouping. So I would look at these first two. The greatest common factor between those is an x. And when I factor that out, I am left with a 3x and a plus 2. Oops, not a 2x, just a 2, plus 2. And then I go back here and they're both negative, so I'm going to factor out a negative 5. And when I do that, negative 15x divided by negative 5 is a positive 3x, and negative 10 divided by negative 5 is a positive 2. And so when I look at the stuff in my parentheses, they are both 3x plus 2. And this is a 3x plus 2. They match. So that is my next factor. Don't forget this 4x. He's still there. He's still out there. Don't forget him. Bring him down. And then the next factor is the 3x plus 2. And then the last factor is going to be the x and the minus 5. This x right here, this x here, I'm going to put there. And that's a little big. And the minus 5 here is going to go right there. And that's my answer in complete factored form. Now, if that had been set equal to 0, because you might have a a problem that says solve this for X. All right, totally different problem. And if it said solve it for X, which means it would be equal to 0, then you'd still have to put it in factored form. And then you'd say, okay, this X right here is 0. This X right here is -2/3. And this X right here would be 5. That'd be taking it to the next level, which is actually what they got you doing on numbers 9 through 13, it looks like. Solve the following using factor method, square root method, or quadratic formula. But I wanted to go over the GCF and the factoring by AC method and grouping to make sure you remembered that. Probably should go over 5 and 6 also, because nobody likes fractions. Y'all in agreement on that? It's been a while since we've done that also. Let's see, I'm going to clear my screen. And let's look at number 5. Number 5 has a 7x over an x squared minus 1 times an x plus 1 over 15x. The only one that I can factor is the x squared minus 1. That will factor to be conjugates of x plus 1, x minus 1, because that's a difference of 2 squares. And then once you get it all factored out, cross cancel, it will, just like you would with regular old fractions. I can cancel this x plus 1 with that x plus 1. And then I can cancel this x with that x, and that is it. 7 doesn't go into 15, so the only thing I'm left with on the top is a 7, and then on the bottom I'm left with this x minus 1 and a 15, and algebraically it should go 15 first and x minus 1 second. So that was number 5. And then number 6, you are subtracting. And in order to subtract fractions, you have to have a common denominator. Well, in order to get a common denominator, I'm going to have to factor out the denominator. So over here, I am looking at this x squared minus 3x plus 2. That would factor to be, I could just unfoil this, x and x, and then 2 factors of a positive 2. Well, there's only 2 factors, 1 and 2. But since it adds up to a -3, these both have to be minuses. And then I'm looking at this guy, the x squared minus x on the other fraction, so minus x over, and he's going to unfoil also to be x and x, and then 2 factors of -2 that add up to -1 would be a +1 and a -2. All right, now get my highlighter out. Both denominators have an x minus 2, so we're good on that. But the first denominator has an x minus 1, which the second one doesn't. So I'm going to have to give him that. But what you do to the bottom, you got to do to the top. So I'm going to have to put an x minus 1 in here.
I think it stopped writing, April. I only have x over x minus 1, x minus 2.
Oh, shoot. Your screen sharing is being paused. How did I do that? Resume share. Ah, well, shoot. Now can you see it?
Yes, ma'am.
Oh, sorry. I guess you missed all my highlighting. Arrgh. Do you want me to start over? Or am I good? So I highlighted the x minus 2's in blue because they both have that. The first denominator has the x minus 1 that the second one didn't, so I had to give it to him, but top and bottom gets it. And then the second denominator has an x plus 1 that the first one doesn't. So I'm going to have to give top and bottom that x plus 1. Now you can see both denominators are identical. They both have an x plus 1 and an x minus 2 and an x minus 1. But before I can subtract my numerators, I'm going to have to distribute. So let's see, at this point, I know my denominators are both identical. They are x minus 1, x minus 2, x plus 1, right? They both got the x plus 1. They both have the x minus 2 and the x minus 1. But let's see, need a different color here, blue. I'm going to distribute the x here. So that's going to give me x squared plus x. And then back here, I'm going to distribute not only the x, but take this minus sign with it. So distribute the minus x. So that's going to be a minus x squared, and then a minus x times a minus 1 makes that a plus x. And then my x squared and minus x squared cancel out. And so what I'm left with is x plus x, which is a 2x for my numerator. And then I have that same denominator of x minus 1, x minus 2, x plus 1. Sorry, my handwriting's awful right there. Too small. Let's go over an inequality with some interval notation. Y'all good with 5 and 6 so I can clear my screen?
Yeah.
Okay. Let's look at number 18. You have to flip the sign on that one. All right, on number 18. First thing I'm going to do over here is distribute the -3 to the 2x plus 4. And that's going to give me -6x minus 12. And then it's still less than -5x plus 6. Now, I got x's on both sides. So when it comes to inequalities, as far as writing them in interval notation or in set builder notation or graphing them, it always makes more sense to me when the x is on the left. So I'm actually going to add 5x over on this one. I know it's going to give me a -x, but I'll deal with that later. So that's going to put all my x's on the left, but in the same step, I don't want my non-x, which is at -12. I don't want that on the left anymore, so I'm going to add 12 to cancel him out. But then I have to add 12 over here. So on the left side of the inequality, I'll be left with a -1x. And on the right, I will have 18. And now I'm going to divide by -1. But a -1 divided by a -1 cancels and you're left with x, but you have to remember that if you ever multiply or divide an inequality by a negative number, you got to switch the sign. So less than now becomes greater than, and positive divided by negative makes it a -18. And it did say solve it, so that's the answer, and then express it in interval notation. If you're also asked to graph, if it's a multiple choice, you'd be looking for the graph that has -18 on it, Because it's not an equal to, you would need a parenthesis and then going in the greater than direction. And that's also how I would write my inequality, or sorry, my interval notation, parenthesis at the -18, and then since it's going to the right, it's going to eventually end at infinity. Remember, interval notation goes from smallest to largest. So if they had given me x is less than or equal to, I don't know, let's say 3, then this is actually starting at -infinity, coming up to the 3 and then including it. Then it would have looked like that. And on a graph, you'd be looking for the 3, and then you would be looking for a bracket that is bracketing in this direction towards -infinity. That's how that one would look. And then let's go over 19, because that one's an absolute value one. Because that's going to end up having 2 answers. And you have to be careful because it could be a what they call an in-betweeny, or it could be one that you have to use a union on. So 19, sorry, I got to clear my screen. 19. Okay. It's the absolute value of -2 times x plus 3, absolute value minus 6 is less than or equal to 8. Okay. I'm just going to go ahead and distribute inside here because it's totally inside of the absolute value. So this would be -2x minus 6. And in the same breath, this minus 6, which is outside the absolute value, I don't want him there anymore. So I'm going to cancel him out. And 8 and 6 is 14. Now, this is where you have to split it into 2 because it's an absolute value. All of this stuff in the absolute value, it could have been positive or negative before you took the absolute value. So you're going to take the -2x minus 6, and you're first going to put it less than or equal to the 14. But then you also have to take the -2x minus 6 and not only change the 14 to its opposite sign, which would be -14, but the less than or equal to also gets changed to its opposite sign, which is greater than or equal to. And you solve both of them individually. So I would add 6 here. That's going to give me -2x is less than or equal to 20. Divide by -2. And of course, when that cancels out, since I divided by a negative, I got to reverse my sign. So that one's x is greater than or equal to -10. And then the other one, I will also start by adding 6. That cancels. I get -2x is greater than or equal to -8. Divide off the -2 so that that cancels. And again, I divided by a negative, so I have to reverse my sign. And -8 divided by -2 is a +4. Okay. In order for me to kind of get a visual on this, I'm going to draw it on a number line because there's 2 of them. Way down here is the -10 and somewhere up here is the 4 and zeros in between. Not that I really need the 0, but just to give you an idea. And this, if I were to graph x is greater than or equal to -10, that would be a bracket right here. And then you're going in the greater than direction. This one is less than or equal to 4. So it would be a bracket on the 4, and then you're going in this direction. And what you're looking for is where they overlap. And where they overlap is right here in between these 2. Boop. So there's my actual answer, and that's exactly how I would write it in an interval. I would write from -10 to 4. And now, if you're not sure, if you're like, did I do that right? Just pick a number somewhere in between -10 and 4 and check it. Go back to the original problem and check it. I would use 0. If I were to put 0 right here, 0 plus 3 is 3. 3 times -2 is -6. The absolute value of -6 is 6. And then 6 minus 6 is 0. And is 0 less than or equal to 8? Yes. I got the right answer. There you go. So you can check them. Questions on that? All right. Jump in anytime if there's something you want to see, if you're looking at it yourselves. Just give me a shout out.
Could you do number 13 on, I guess it's test number uno, dos, tres? It says, give an example of a polynomial of a degree 4 with only 2 real zeros.
Yes. Yeah, now on that one, answers would vary. So more than likely, if they put a question like that on the final, or if I do, it would have to be multiple choice because there's no way to answer them in there. But if it's a degree 4, that means your x's, the exponents on your x's, all have to add up to 4. But because you can only have 2 real zeros, the easiest way to do that is to give me some binomial, x plus 1, and put a squared on it. And then give me another one like x plus 7 and put a squared on it. Because then this real number is a -1, but it is of a multiplicity of 2. That means you have x plus 1 times another x plus 1. So you'd get x equals -1 twice. And then this one, the real 0 would be -7, but it also has a multiplicity of 2. So I'm only getting, 2 real zeros right here. But because this is squared and this is squared, x squared times x squared would be x to the 4th, and that would be a degree 4. Does that make sense? Because I think, what did I have for my answer? Hello? I lost that page. Oh no, what did I do with it? Huh. Well, I seem to have misplaced that page of my answer key. Oh well, but does that make sense what I did? It was James, right, that asked that question?
Yeah, it's easy. I just didn't see it.
Oh, that's okay. I know we just went over logarithms and stuff, so is there any, I mean, we did that last week, but was there any questions on any of the logarithm stuff you want to see again?
Would you do number 1 on test 4 material?
Yes. Let's see. Now that graph actually goes to number 2. That graph, if you're looking at this over here, it's like this. It says find f of g of x and g of f of x for f of x equals 3x squared plus 2 and g of x equals, and what does this mean about f of x and g of x? Okay. Let me shrink it down a little bit, give me more room. All right, I'm going to make f of x red. G of X blue. Not implying anything about Kentucky basketball at all. Go Cards. All right. You want f of G of X. That's where you're literally putting the blue function into the red function where the X is. So you're literally taking this mess and putting it in place of this X right here. So this is, instead of 3x squared plus 2, it's going to be 3 big old mess squared plus 2. I'm literally going to put this square root of x minus 2 over 3 where the x was in the red function, and then simplify it. Because you have this squared right here, this squared is going to literally cancel out the square root sign. So you're still going to have the 3 and the x minus 2 over 3 inside the parentheses, but the square root sign is gone. And then, since I'm multiplying 3 times that, this is like 3 over 1, so the 3's cross cancel. So what I'm left with is the x minus 2, and then that red plus 2. And of course, the minus 2 and the plus 2 cancel out, and I'm just left with x. So that's f of G of X. Then they want me to figure out G of f of X. Okay. Erase this. And now this time we are going to put, you're putting the red function into the blue function. So I'm going to take this mess and put it over here into this one where the x is. So this is now going to be the square root of, instead of x minus 2 all over 3, it's going to be a 3x squared plus 2 minus 2 all over 3. And now you have to simplify that mess. And then the first thing that will happen in this one is in the numerator, the plus 2 and the minus 2 will cancel out. So I'll still have the 3x squared on the top and the 3 on the bottom. And then the 3's will cancel out. So I'll be left with the square root of the x squared. But if you square root an x squared, you're just left with x. And that's that answer. And then they ask you, what does this mean about f of x and g of x? If they both come up equal to the answer of x, that means they are inverses of each other. They are inverses of each other. That's all that means. They're symmetric around the y equals x. If you were to graph them, they would be mirror images along that diagonal line. Oh, I'm sorry, I'm yawning. Oh, sorry, sometimes math just bores me. Sorry, I'm so, math. Y'all know what math stands for, don't you? Mental abuse to humans. Feel free to laugh. Nobody's laughing. I'm laughing at myself. Is anybody out there? All right. Let's see. What other problems can I? Oh, transformation on graphs. Let's go over one of those. Get this thing out of my way. There we go. Let's look at number 6. It says graph f of x equals 3 raised to the x plus 2 plus 5. Okay. I always start out with the basic graph of y is equal to 3 to the x. That is an exponential graph. They go through 0, 1 right here. They run along, let's see, I'll do this in yellow. They run along the x-axis and then they curve, go through 0, 1, and then they shoot up. That's the basic graph of an exponential. But what we're about to do is to the x, we are going to add a 2. And then to the entire function, we're going to add a 5. All right. Now, the plus 5 right here, that is going to shift up 5 units. But this plus 2 right here is going to shift to now remember, when it's up in the exponent, it moves it horizontally and it'll be the opposite. So if I see plus 2, I don't go 2 to the right, I go 2 to the left. So it'll shift to the left 2 units. So if I use this point right here as my main point, for the green, it's going to shift it 2 to the left. So it's going to go 1, 2. So the graph is now going to look like something like that. But then from there, you're going to shift it up 5. So 1, 2, 3, 4, 5. It's going to go here, which means it has a new asymptote. The asymptote, which was the x-axis, is now going to be one below that red dot, which will be right here. And so my final graph in red will be, looks like that. Again, in my math lab, it'll just be multiple choice, or you'll have that little, the graph that actually graphs the yellow first for you, and then it tells you to shift, you know, you just click on the little things and it moves it for you. So
does the 3 stretch it?
No, no.
I'm thinking of something else. Okay.
Yeah. You're thinking of, is there one in here? Like on a parabola or something. If I had just, let's see, let me erase this here, clear my screen. If you were given, let's see, y equals negative 2x squared minus 3, something like that. You'd be starting with y is equal to x squared, which basically looks, you know, something like this. But then if you, let's see, I'm going to start with the minus 3. The minus 3 is going to shift it down 3. So 1, 2, 3. So that's going to move it down here. So it now looks something like that. And then the negative, you've got this negative here. That's going to reflect it around the x-axis. So this thing will literally flip. It'll flip around these 2 points right here, flip it around. So now, this graph is going to be in red. This point's going to be here, and it's going to be going like this now. And then the 2 right here is actually going to stretch it, like pull it tight along the y-axis. So it's actually going to get sucked in a little bit more like that when you're done. it sucks it in. Had that been a 1/2, let's say it had been a 1/2 x squared, then it would have stretched it out more like that. That's what that coefficient does.
Can we do number 14 about on test 3?
Yes. I think that's supposed to say, is this graph a function? It says this. Is this graph the graph of a function? Yes. Now let me come over on this one now. Because this passes the vertical line test. If you draw a vertical line anywhere through here, it only crosses it once. That determines if it's a function. They're not asking on this one, but just to go over it, this is not a one-to-one function because it doesn't pass the horizontal line test. One-to-one means that every x has one and only one y to go with it, period. They didn't ask that question on this, but yes, it's a function. So this is yes, passes that. What are the x intercepts? My x intercepts, there's 3 of them. This one, and this one, and this one. They want them as ordered pairs. So now this one was sneaky, and I hope I fixed it on my answer key. Yes, I did. Because at first I was like, wasn't paying attention, and I saw each one of those lines as a 1, and then I noticed how they labeled the y-axis. They label every little square by 2. So if I'm, paying attention, this would be -2, this would be -4, this would be +2, +4, +6. So my ordered pairs, this point right here would be -4, 0. And this point would be -2, 0. And this one would be +2, 0. That's part B. Part B I did in yellow. And then part C, what is the y-intercept? That's this one right here. And the y-intercept would be when x is 0, and then you drop down to -2 on the y-axis. And then they ask about local maxima and local minima. When they use the word local, that is simply where it's a high point or a low point on a curve. So, and my eyeballs, I'm gonna have to erase everything I wrote up here so I can highlight that now. Purple. Okay, so local maxima, if you're looking at this curve right here, it has a local maxima right in the middle of it, which would be right here. And so estimating that, that's halfway in between the -2 and the -4. And they want to know what is the x value of the local maxima. So the x value, I would say, is -3 on that one. And then the next one, E, what is the x value of the minima? And the minima would be this curve here. So I'm looking at about right there. Oh, I'm gonna say 1/2. I'm estimating there. It's not a very good picture, so 1/2. Because this is 2, so halfway would be 1, and then it looks like it's halfway in between there, so I'm going with 1/2. That's why I put little approximadoxalies on there. Little approximation symbols, squiggly equal signs. Does that help?
Yes, it does. And would you do one more on test 3, number 14? That was test 4, I believe. The test before that. Finding the zeros. No,
Going the wrong way?
right there. Wait. No, that's the one we just did. Hold on. I'm looking. I'll shut up after this question.
No. Ask as many as you want. Here it is.
There you go. That's it.
Yep. Find the zeros on that. Okay. All right, if you're looking for the zeros, you're literally looking for when this guy is equal to 0. And I will tell you right now, I am definitely not going to do a problem like 15 on your test. So where you have to use synthetic division and all that crap. I ain't putting it on there.
That's right. Yeah.
I ain't doing it. So set this equal to 0 and factor it. The first two, I have to simply do factoring by grouping on this because it's an x cubed. I can pull out an x squared from the first two. That'll leave me with an x plus 3. And from the back two, a negative 4, because that will also leave me with an x plus 3. So that's my first. When I look at all of this and all of this, it's like, look at the stuff in front of the minus sign and look at the stuff behind it. And what they have in common is this x plus 3. So I pull that out. That's my first factor, is the x plus 3. And then you have to look at what's left. Well, if I pull the x plus 3 away from this, what I'm left with is this x squared, because I pulled the x plus 3 out. So the x squared has to go right here. And then behind the minus sign, because here's the minus sign, this minus sign, that's right there. When I look at behind the minus sign, I've got this 4 left. That's what's going to go right here. But I'm not done, because that x squared minus 4, that is factorable also. That's a difference of 2 squares. And I can factor that into conjugates, x and x for the x squared. The square root of 4 is 2, so it's 2 and 2, but one's a plus and the other one's a minus. Once you get it all factored out, either the x plus 3 is your 0, the x plus 2 is your 0, or the x minus 2 is your 0, which means this x right here would have to be a negative 3 to get a 0. This x would have to be a negative 2 to make it a 0. And this x would have to be a positive 2, because 2 minus 2 is 0. And those are my zeros for number 14. This was the first test. No, second test, number 10. Yeah, I want to look at number 10 real quick on the second test. It says their second test review, chapter 2, was it? It just asks for the domain, but they want it in interval notation. So, are we good with what I just did here on this one? I'm gonna erase it.
Yep.
Okay, number 10. If you're looking for the domain, it's what x is. And normally x is all real numbers from negative infinity to positive infinity, unless you have an x in a denominator or an x under a radical. Fraction land and radical land cause problems with the domain. This one is in fraction land. And basically you just look at the denominator and you have to say, okay, the denominator is not allowed to equal 0. So any x that causes a 0 cannot be in the domain. And this is actually factorable. That's a difference of 2 squares. It's x, and then a positive 13 and a negative 13. So this x cannot equal negative 13, and this x cannot equal positive 13. So if they said put it in set builder notation, then I would have said it's the set of all x such that x cannot equal negative 13 comma positive 13, and I'd be done. But no, they want interval notation. Well, for interval notation, sometimes it helps to see this on a graph. Here's my number line. Negative infinity is way down here, positive infinity is up here, and on my number line, here is the negative 13, and up here is the positive 13. Those are the two numbers that you cannot let x be. So if you remember, like algebra in high school, they used to use open circles and solid dots. So for this, I'm going to do that. I can have, let's see, I'll use a highlighter. I can go from here up to the negative 13, but not include it. And then I can go between the negative 13 and the positive and 13, but not include either of those. And then I can go from 13 to infinity. So if I'm to write the domain in interval notation, the first one is going to be from negative infinity up to the negative 13. Use a parenthesis because you're not allowed to include it. That is what I highlighted on the number line in pink. Then you use one of these little symbols, the union symbol. And then the next interval goes between negative 13 and positive 13, but you have to use parentheses because it cannot equal those. Then use another little symbol, union symbol again. And then the last interval goes from the other side of 13 to the infinity. And that would be what the green part of the graph looks like. And that would be my answer in interval notation. So you're using, parentheses right here and here and here on those 13s and negative 13s because it's like an open circle. You cannot include that number.
Oh, heck. Would you do number 16, the very last question?
Sure. The formula, it says A of t is equal to A sub 0 always means your initial amount, whatever it is. On this problem, however, they don't tell me what it is, but they want to know the half-life, meaning whatever your initial amount is, the half-life is literally half of what you started with. So you take out A of t and put in 1/2 of A sub 0. Because it doesn't really matter what A sub 0 is. If it's 500, I'd have half of 500, which is, 250. When you divide, you'd get 0.5. So the 1/2s literally cancel out. And I'm going to switch my 1/2 to a decimal. So I have 0.5 equals the e to the negative 0.5t. That's what you do in a half-life. It's just going to be half of whatever it was to start with. So if A sub 0 was 1,000 and half of it is 500, 1,000 goes into a 500 0.5 times. You'll always get 0.5 no matter what your initial amount is. And then this is exponential, but I can't solve it exponentially because there's no way to make base E into a base 5. So we're heading to log land. Remember that logarithm, since this is base E, I'm going to have to go with the natural log of base E, which is really invisible. And you'll take the natural log of the 0.5, and then that's going to equal the exponent of negative 0.05t. And then you'll just divide both sides by negative 0.5. So in my calculator, I will have to, let's see, for this calculator, you're going to have to hit the 0.5 first. Then you hit your natural log button, which is capital LN, but whatever. And then you're going to hit the divide sign. And then you will hit type in 0.05. And then hit the plus minus button at the bottom. It has these like little arrow thingies to make it a negative 0.05. And then hit your equal sign. And it didn't tell me where to round off, but it's 13 point, we'll say 86 to 2 decimal places. T is in years. What is the half-life? So it'll take approximately 13.86 years for it to be half of what it was to begin with. And I'm out of time. Well, you guys have my phone number, so if there's anything else you need me to, go over, or you want me to do a quick video of, just let me know and I can do that between now and Wednesday. And like I said, I posted an announcement right before this class started about the final, which is on Wednesday. We're done with Zoom meetings. You just log in my math lab at 4 o'clock. It'll open up at 4 o'clock and it'll close 4 hours later. So that should have plenty of time. There's 40 questions. You can use your calculator, you can use your notes, have blank paper, and show me all your work. Number your problems. I will not look at problems if it's like scrap paper and it's written all over the place. I'm not playing Where's Waldo. So number it, make it neat so I can read it if I need to. So, okay. I'm done. You've been a lovely audience. Tip your waitresses.
Thank you.
Thank you for class.
You're welcome. Merry Christmas.
You too. Merry Christmas.